This video is entitled First Normal Form and goes along with the database BUIS 2400 course. I'm Dr. Renault, and I'll be taking you through this introduction into what it means to be first normal. In this video, I'm going to define what first normal in database normalization means, and I'm going to discuss and have a whole bunch of examples about moving raw data into first normal form. First normal. In first normal, there are really 5 things that we need to do to the raw data that our client has given us to actually get it to be able to put into a database. Now, it's not perfect, it's actually not very good at this point, but it's the first step of taking that raw data and analyzing that raw data and getting it into a database. So there are 5 properties of first normal. The first property is the data must be unique. Each row has to be unique. Number 2, the order of the rows is unimportant and the order of the columns is unimportant. You're going to see some examples where if we were to sort the spreadsheet they gave us or sort the data by columns or sort it by rows or rearrange columns and rows, we lose information. So we need to make sure that no data, no information is lost. We need to eliminate multi-values. So if you have one attribute, one entity that has multiple values in it, we need to eliminate all of those. If an attribute is complex, it contains a lot of stuff, and we may want to query, we may want to think about it in its pieces. We need to break those up. In the decision whether an attribute is complex or not is kind of business rules. There's a word you'll hear used, atomic, that you've got to get it down to the atomic level. But atomicity is not exactly what you want. That's a very specific term in computer science. But let's just think about it as if it's a complex entity, a complex attribute, complex data element. We need to get it down and break it up into its less complex pieces. And then lastly, the fifth property of data when it's in first normal form is that every row must have a unique primary key. Now, the primary key can be a single value. Primary key can be concatenated elements, concatenated data elements or attributes, or we may just throw in a surrogate key, put a number and say, good enough, that's a primary key. So a primary, it must have a primary key. And in the examples, you'll see me do all 3 of those to create a primary key. So let's say your client gave you this little spreadsheet, and it's a whole lot bigger than this, but there's a little sample of the spreadsheet, and it's information about the client's customers. It contains customer number, name, address, city, state, zip, their phone numbers, the salesperson number and name, and then their email address, the customer's email address. Well, let's look at the 5 points that I said. Is it unique? Well, yeah, each row is unique. Okay, great. Meets that criteria. Could we sort that? Uh, could we sort that spreadsheet into any order of columns or any order of rows? Could we shuffle the columns around? Is it going to lose the information? No. Is it going to lose any meaning? No. Cool. We got those. Now let's look at primary key. Do we have a primary key? Yeah, we've got a customer number. That would be unique. That's a nice primary key. It's one attribute, simple. Great. So we've got 3. Now, do we have are all of the attributes simple? And I'm going to say the answer is no. Because look at name. Name is last name, comma, first name. Would we ever want to print it out first name, last name? Would we ever want to so I think that data element needs to be split into 2, just because it's kind of messy. Um, What happens if a customer service representative were to enter some people first name, last name, and others last name, comma, first name? And no, that's a mess. So let's fix that. Let's break that into two attributes. Also, let's look at the column city, state, zip. Wouldn't it make sense to split the city, the state, and the zip code into three separate attributes? I think it would. Probably even adding a fourth attribute, which would be country, because so many of us are dealing with internationalization, international data, customers across international borders. As we become more of a global economy, this probably needs a fourth column also for country. So you can see that those attributes need to be simplified. Can we simplify the email address into two? You could split it at the at and put part in one and part in another, but that's a real pain. You don't need to do that. That's kind of, is it atomic? Not quite. Does it meet the business rules? Yeah, leave it like it is. Phone number. That phone number attribute, that phone number column has a problem. It's got multi-values in it. Let's fix the simples first. So you can see that I've broken up the name attribute and the city, state, zip attributes into simpler attributes. I've broken up name into three attributes: last name, first name, and initial. Because there was one customer with an initial. So but I could have put that in the first name, but business rule, I thought that would work. Also, then notice city, state, zip became three attributes. This way, I could say, show me all of my customers in Ohio. Boom, easy. I could say, show me all of my customers in this zip code. Boom, easy. Now that I've got them split up. Now, I still have a problem with the multi-value, and we handle that by taking the multi-value and putting it into another table and often creating a concatenated key. So what I did was I took the multi-valued telephone number field and brought it out into a new second table. The primary key would be customer number, phone number, because that would be unique. And there are no non-primary key elements in this table. But you can see that now customer 101 has his two phone numbers. Customer number 201 has their one phone number. Customer 374 has their two phone numbers, and customer 83 has no phone numbers. So you can, by creating this second table, we've now eliminated the issue. And we also have to ask ourselves, does the second table meet first normal guidelines also? Because we've created a new table. Any change we make, we have to go back and make sure that everything still is simple and unique and all multi-value, not multi-value, and has a primary key. But with this, you can see that we've now taken the customer spreadsheet that was kind of a mess, and we've cleaned it up and turned it into two tables. The entity relationship diagram would look something like this. A customer can have 0 or more phones, and a phone has one and only one customer. The primary key of the customer table is also a concatenated primary key and foreign key of the phone table. And the question is, why didn't I just use the phone and use the attribute as the customer as an attribute? Well, what happens if you have one phone that's shared by two customers? Husband and wife are two independent customers. He orders things, she orders things, but they only have one home phone. That would kind of make sense, wouldn't it? So this takes care of that problem, that a phone could have many customers and a customer can have many phones. So by doing it this way, we've eliminated that issue. So that's the customer example. Let's look at another example. In this example, and you'll see this example through first normal, second normal, and third normal. In this example, we have a customer that wants to track its purchases. And so a purchase order is a document that a business creates. Well, lots of businesses create when they want to buy something. And a purchase order says to a vendor, hey, I want to buy these things from you. So here we go. Let's look at it. They gave us a spreadsheet that looks like this. It's got purchase order date, vendor number, vendor name, product name, and that's our product within the company. And then notice there's vendor product, which is the number that the vendor uses to track the product, which is different than our number because we have our inventory process and they have their inventory process. And then lastly, the column would be how many we ordered. What's the quantity we ordered? So you can see that like product S12, the 120 volt ivory switch that looks something like this. You've got them on the wall in your home. I can purchase that from XYZ Supply, and I've also other times purchased it from USA Wholesale because it's a pretty standard kind of thing. Doesn't matter where I buy it from. Um, and one might call it one thing and one might call it something else. So that's why they have different vendor product numbers. Here we go. Are the rows unique? And I think the answer to that would be no, because look at that second row of O12 G777X for 20. Notice that that's on purchase order 101 and on purchase order 112. So I bought 20 of them from XYZ Supply on the 20th, and I bought 20 more of them on the 22nd. So the rows aren't unique. You'd think they might be, but they're not. Would the order matter? If I shuffled that right now, would things get lost? Yes, because some of those rows don't have what purchase order they belong to or what vendor they belong to. So if we were to sort that spreadsheet, we've just messed everything up. Is every attribute simple? Well, purchase order, yeah. Date, yeah. Vendor number, yeah. Name, yeah. Product, yeah. Product name, yeah. They're all simple. Nice. Do we have any multi-values? Well, there's a name in the comma, or there's a comma in the name over here of our vendors, but that's part of their name, the comma. That's not a separate attribute. So yeah, I think we have no multi-value. So we pass that one. Do we have a primary key that defines each row independently? No, no, because 3 rows are on that purchase order, and product S12 appears on multiple purchase orders. Nope, nope, there's no primary key at this point. So we're simple. We have no multi-values, but we don't meet the other 3 criteria. Let's start fixing them. So to fix the order problem, I just repeat the purchase order information for every line, fill in all the blank information, and now if I were to sort it, or if I were to shuffle it and then try to sort it, I'd be right back to where I was, wouldn't I? So now I've fixed the order problem. And I've also fixed the unique problem because now each row is unique. Excellent. So I've got unique, order, simple, multi-value. I need to come up with a primary key. What would I use for a primary key? Well, what am I going to use for a primary key? Well, I think I'm going to concatenate a primary key at this point. I think I'm going to take the purchase order number and the product number because the product only appears once on a purchase order because we're buying 10 of these and 20 of those. And I'm going to say let's concatenate those as the primary key. So the primary key for row 1 would be purchase order 101, product S12. The primary key for row 2 would be 101, item number O12. And then the data is there. So we've now got it to first normal form. I've got a primary key. I have no multi-values. Everything is nice and simple. I've got the order that I can shuffle it in any order I want and I can bring it back to the way I want it before. And every row is unique. Excellent. So I've got purchase order information into first normal. And a simple entity relationship diagram for my purchases would look something like that, with purchase order number and product number being my primary key and everything else just being attributes. Let's look at a third example. Not four. Let's look at a third example. This example is a package shipping company. You know, think like the Postal Service or think like United Parcel Service, but this is Jim Parcel Service, JPS. We lose things all the time. This is our tracking spreadsheet. think about let's look at the data. We've got a package number, tracking number X4567. We pick it up in Peoria, Illinois, and it's coming to Portsmouth, Ohio. Excellent. And we enter it into the system at one point. We pick it up at another point. It's sorted in our Chicago sorting facility at one date and time. It's sorted again in our Columbus shipping facility. And then it's finally delivered in Portsmouth. And we can see the dates and times of all of those things happening. We've got another package that we're picking up in Portsmouth and taking to the courthouse, the Capitol Square in Columbus, and we've entered it into the system to tell us to pick it up, and then we've picked it up, but we've not sorted it or delivered it or anything. It's still kind of floating around in the system. Would you use something like this? Yeah, you go to a website all the time and type in your tracking number and see all the places it's been and all of the dates and times it's been touched by the system. So would this spreadsheet exist in any kind of shipping company, product tracking company, something like this? Yeah. Let's look. Are they unique? Well, no. No, because I could have 2 items sorted at exactly the same time in the same facility. So are the rows unique? No. Could I sort it and lose data? Yeah, so the order isn't going to work because there's blank stuff. Um, are the attributes simple? No. Look at all of those city, states, and zips. That's not simple. Do we have any multi-values? Oh, yay, we don't have any multi-values. Do we have a good primary key at this point? No. No. So let's fix the order problem and the unique problem first. So by repeating the tracking number and all of the all of the package information on every row, we've now fixed the unique problem and we fixed the order problem. Now, we still have the simple problem. So on the next slide, you're going to see me fix all of the addresses into their simple format. So I've simplified the addresses and broke them up. And yeah, I probably should add country because I might ship to some other country somewhere. Um, but we need to now come up with a primary key. I could add a surrogate key and just number them rows 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm going to concatenate 2 attributes together. And the attributes I'm going to concatenate together are the package and the activity date and time. Because business rule, this is Jim shipping. We lose things. We have a rule that says you can only do one activity to a package. Okay, so let's look. Package activity. So we entered it in the system, was done at a certain date and time. Maybe 3 seconds later we picked it up, but that was 3 seconds later. So that would be a different date and time. So I concatenate package number or tracking number and activity date and time, and I've now got a good primary key. Every row is unique. I've got a primary key, no multi-values. I've simplified everything, and the order could be any which way I want in rows and columns, and guess what? I've got my package data into first normal form. And the entity relationship diagram would look like that, with the tracking number and the activity date time being the primary keys, and then all of the attributes, delivery address, delivery state, city, state, zip, activity, code activity, description, city, state, zip, they're all there. Rock and roll, we're in first normal form. Fourth example, I've got a spreadsheet of all of my friends. I've got a column that's their last name. I've got a column that's their first name. I've got a column called nickname that I can put a nickname for some people. I've got a column called children where I put the people's children if they have any, and I leave it blank if they don't. And then I've got a column called hobbies that I type in the hobbies that my friends have so that because I've got thousands of friends. Yeah, right. Um, but it's kind of nice to keep track of who's interested in what. Maybe if I'm having a party about something, I might want to invite some friends, but not others because they might not be interested. Um, so I've got this spreadsheet and I'd like to turn it into a database. Is each row unique? Yes. Is the order important? Could I shuffle the rows, shuffle the columns, and still be okay? Yeah. Are each of the attributes simple? Well, yeah, they're simple, but I've got all kinds of multi-values, don't I? And the children and the hobbies. Do I have a primary key? No. So I've got some problems with this. I'm close in some ways and far away in others. Now, notice, well, let's just go ahead. We're going to start getting rid of, well, first we've got to come up with a primary key. There's not really a good attribute or group of attributes that would make a good primary key. Um, People's names can change. Maybe my friend Debbie got married and she changed her last name. So I can't use last name as primary key because, well, it's not unique either. I couldn't concatenate last name and first name. Okay, not everybody's got a nickname. Yeah, I don't have a primary key. So I'm just going to say, let's throw a surrogate key at it. I'll just assign each friend a friend number. So I've assigned each friend a friend number, and I've now called it the primary key. So I'm now going to create a couple of tables to handle the multi-value problem. Now, my friend Bob Newhart, actually, he used to have a TV show, and there were three fellows on his show, Daryl, and his brother Daryl. It was kind of funny that Daryl, and Daryl. But well, there are people that have named multiple sons and multiple daughters the same name. It's confusing, but it's not against the law. So to fix this, I've had to add kind of another surrogate key in there, and you can see that in the children table, I've said, well, person 1 has one child, Anna. Person 3 has one child, Daryl. Second child is Daryl, and the third child is Daryl. So he's got three Daryls. Because I couldn't concatenate person ID and name together because that wouldn't be unique. So I've now got the first child, second child, third child, fourth child for each person. Um, then I've created another table called hobbies, and I've got the friend ID as hobby, and I've got the hobby that the friend. And if I concatenate those together, it's a primary key. Is it a good primary key? No, because the hobbies are kind of these big long strings, and I could misspell it, or finding all of the people that are interested in solving crimes. I've got some friends that are amateur sleuths. um, I don't like that as a done deal. I want to fix the primary key of the hobby table, and I'm going to do that by, watch this, I'm going to do it by creating a new table called hobby. And I'm going to assign each hobby a hobby code, like amateur radios or hams. And people that are into dining out and eating in restaurants would have an R. My motorcycle friends have a hobby of MC, and I'm going to assign each hobby a code. That way, um, I can, in my hobbies table, just save the friend ID and the hobby code. So it's now a really nice primary key over here in the hobbies table. There's a really nice primary key in the hobby table. My children look good. My friends didn't change. So that one friend's spreadsheet has now become four tables with all kinds of relationships between the tables. Is it unique? Everything is. All four tables. Order independent, all four tables. Everything simple, all four tables. Do we have any multi-values? No. We're good. Do we have good primary keys everywhere? Excellent. So we're in first normal form. Now, we also happen to be in second normal and third normal form, but I've not defined what those are yet, but you'll see those in subsequent videos. Here would be an entity relationship diagram for friends. A friend has 0 or more children. A child belongs to one and only one friend. Well, that could be a little wrong because what happens if I've got husband and wife in here or a mother and father in here and but but the way I set it up, that business rule still applies and that'll work good enough. Um, a friend has 0 or more hobbies, and a hobby belongs to the hobbies record belongs to one and only one friend. A hobby code can be assigned. So the table there in the middle of hobbies allows for a many to many relationship between friends and hobby. A friend can have many hobbies and a hobby can have many friends. So we eliminate that many to many relationship with this table in the middle. So there would be the entity relationship diagram going along with the friends that we've taken through first normal, and we're also in second, third normal, even though you don't know what that means yet. This concludes this brief introduction into first normal, and I'd like to say thank you for watching. This has been a long video, but there's a lot of great information. I hope the examples were helpful. This presentation is copyright 2020 by James Zimmerno, PhD. You can contact me at jrenault@shawnee.edu with any questions or issues. This work is licensed under Creative Commons Attribution, non-commercial, share alike 4.0 international license. And again, thanks for watching.